This tutorial will cover how to scan a room rapidly, accurately, and effectively with Dot3D. As you see, we're walking into an electrical maintenance room that we'll be scanning, and the first step is to take a look at your scene and prepare it for scanning. So you'll notice I've scattered a set of 10 of our AprilTag targets throughout my scene, evenly across different elevations, while also strategically placing 3 at my start and finish point in the corner of the room, and setting them up so that I can take some measurements to reference, in this case, of the height, the width, and the length of the room, which will tie in during my optimization and automatically improve the accuracy of my data set, especially for larger room scans. Step 2 is to select your hardware, of which we have a wide variety of options. First, we need to select a compatible tablet or phone. The options include Windows tablets, Android tablets, or Android phones. We also support ruggedized versions of all of the above. In this case, we'll be selecting the Samsung Galaxy Note 20 Android phone. Next, we need to select a 3D depth camera. The options include the DPI-10 for versatile indoor scanning, the DPI-10 SR for short-range indoor scanning, the Intel RealSense D415 or D455 for outdoor scanning in sunlight, or in this case, the L515 LiDAR camera, which offers extended range and improved accuracy in indoor settings without significant ambient lighting, such as the room we're in today. It also provides convenient form factor and compatibility with a phone-based system, and you can attach it directly using the Dot product magnetic mounting kit and included USB-C to C cable. The next step is to open up Dot3D and begin scanning on your phone or tablet.
So here we are in Dot3D Pro, running Dot3D 4.0 with the Intel RealSense L515 depth camera to scan an electrical maintenance room. So I'm going to go ahead and press the new scan button now that I have my L515 connected, and Dot3D will connect to the Intel camera, and now we see what the camera sees. You'll notice that I have 2 or 3 AprilTags at my start point in the corner of the room. This is definitely a best practice you want to follow on really every scan, as long as you have the opportunity to put up a couple tags. For this workflow, they don't even need to be measured or have any additional input whatsoever. As long as you start at them and finish back at them, they will automatically improve the quality of your data. Additionally, you'll notice that the start and stop button on the right side of the screen has a green circle around it. That's telling you how well the device is tracking. It's called the scene fitness. So you want to pick an area of good scene fitness to start your scan. If I get in close to a flat wall or too far away, you'll see that bar go down. But if I'm pointing at the corner of the room, for example, some very recognizable geometry, it's tracking very well, and this is a good start point. To start your scan, you just press the button, and you're immediately capturing a color point cloud data set of everything you pointed at. The green and yellow is real-time feedback on the quality of the points you're collecting based on angle, distance, time on target, reflectivity, etc., all being taken into account on the fly for real-time quality feedback. So you just want to slowly move through your scene and fill in all the areas of interest, turning them green or at least yellow until you're satisfied. You'll notice the AprilTags turn orange automatically. You want to make sure that you turn them orange at the beginning and the end of the scan as far as these 3 go. And also you want to make sure that you turn each of the AprilTags we measured earlier orange, so you'll be able to properly implement those measurements before optimization. The buttons that you have at your disposal here in the software while scanning include the HD photo capability, which allows me to zoom in here and then press and hold to capture a high resolution image from my phone or tablet camera, which will be built into Dot3D with my viewpoint and location of the photo capture. You also have the plane picking function on the bottom left, which allows you to flag any level surfaces in your scan. So if you're in an indoor environment where you trust the floor and walls as being flat and level, you can flag them as such while scanning by just tapping that button on the bottom left whenever your crosshair is pointed at a parallel plane like a floor or a wall. And that's just an optional workflow that will, similar to the targets, help improve your optimization behind the scenes. The last button that you have here is the scan time annotation capability, this crosshair icon. And that allows me to flag something in my scan that I'm going to want to add notes to after the fact, or something that needs to be documented. So in this case, for example, if I wanted to flag the fire alarm, I just press and hold that button and release. And that will add an annotation to that point and prompt me after I finish my scan to fill in all the relevant details. You'll notice that I can see the ceiling very easily with this L515 camera. The extended range for fully indoor scanning is definitely one of the major benefits of this particular camera model versus some of the other options you have in Dot3D. However, you'll also notice that it does struggle a little bit more with the black trash can here. That is a drawback of the L515 and something you have to be aware of if you have a lot of black in your scene or shiny objects. Just getting a little bit closer to fill them in a little bit more nicely. So as I continue to move through my scene, I want to make sure that I turn
everything green or at least yellow.
Whatever is most important, you want to try and get in a little bit closer, turn a little bit more green if you can, but even yellow is generally good, especially with this L515 camera, which has some great accuracy at depth. Anytime I'm pointing at the floor, I'll use that plane picking option on the left. That's a good best practice. And you'll notice me looping over those AprilTags whenever I have the opportunity and making sure that I've captured each of the 6 that we measured. Now the camera can only see what it can see, so if I needed to get information on the top of these electrical panels, for example, you might want to consider mounting it to a pole kit or just stretching up a little higher like I am right now to get that additional information. If you feel like you're happy with everything you've turned green and you want to take a look at your data set, you always want to make sure you finish back at those same AprilTags and press the button that you started with again on the right to finish your scan. The data will process locally on your device in a matter of seconds and give you an immediate preview of your scan in the unoptimized format. So here we see our unoptimized data set. This is by no means the final result, but it's a chance to make sure that we got everything that we need. So this is an opportunity just to see if there's any holes or gaps in your data, any areas that you wanted to capture some more detail on. So for example, the stack over on the pallet in the corner here, we can probably get some more detail on that over there on the left. We also have a little bit of a hole in the floor that we want to try and fill in. So to do that, before I optimize, I go back to my Scan tab and select Append. And this gives you a collection of frames to choose from to then relocalize and add back into your data set before optimizing. So you want to select a frame that's relatively near the area that you want to add and looks like it has some recognizable geometry that you can easily reposition yourself in. So I'll select frame 24 in this case and allow the sensor to reconnect to my camera automatically. And now it gives me this translucent overlay, which I want to line up with reality. So if I move that over to line it up, it'll automatically find itself, and I can go in and add some of that more detail that I missed the first time. Anytime you're using the append feature and you happen to have some AprilTags nearby, you should utilize that same workflow as earlier, capture them and finish back at them during your scan. And this is just my chance to add a little bit more detail that we didn't get on this particular area in the initial scan. And then I also noted that I wanted to fill in that hole in the floor that I didn't catch from the first scan. So I'll walk around here one more time, making sure I fill that in nicely. Also taking advantage of that plane picking button whenever I have the option. Now I'll loop over these AprilTags as a best practice and finish back at the one that I started this append from. Press that same button on the right to finish your scan. Now this is going to add our second scan directly into our first scan before we optimize it into a single file. So now we can zoom out and take a look and make sure we got everything we need. So we'll see that that hole in the floor was filled in and that we've added a lot more detail over here on this pile on the pallet over here. Again, this is our unoptimized data, so if it looks a little fuzzy or anything, that's completely normal. The next step is going to be to optimize. But in this case, before we optimize, we want to add those reference measurements, which really helps tie down the accuracy of your data, especially across different room sizes, different sensors that you might be utilizing, and it just adds the confidence of knowing that you reference some known measurements in your scene. So if I go to Edit, Targets, this is going to allow me to input those measurements that we took earlier. I want to leave it checked to use AprilTag targets because that's what I have in this scene, although you can also do this with standard checkerboard targets if you don't have AprilTags in your situation. So I press Next. And now I want to create each of those 6 targets in my scene. So I just want to go to press the plus button, and then you'll see this select option, which shows you all of the different tags that were automatically recognized by Dot3D during your scan. So I'm going to create each of the 6, which are 133 as a scale target, create. 137 as a scale target, create. 184. 143. 206. And 187. So now I see I have each of those 6 targets with no XYZ coordinates. This is a very similar workflow. If I did happen to have known coordinates for those targets, you'd put those in here, but in this case it's just a measurement. So I've created the targets without coordinates, and on the right side I want to add the reference distances. So I hit plus, and I'll select the measurement from 137 to 184, which is 263.13 inches. Now I'll do that 2 more times for my other measurements, which encompass my length, width, and height of my room. When you're using scale bar targeting, you want to do your best to capture the longest distances you can across all 3 axes if possible. This time it's going to be from 133 to 143, and the measurement is 150 exactly. And lastly, I want to add the distance from 206 to 187 as 70.38 inches. Now you want to double check, make sure you have your measurements input properly, and then you can just press Next. If you need to check your measurements, you can do View/Change Associations, and this will just show you that each of these measurements that we've referenced is approximately in the right place. I mean, more than approximately, especially on a nice tight scan like this, it's probably already going to be very accurate. But if you saw that green circle, way off, that would indicate that you probably typed something in wrong. So it's a nice way to double check, but everything looks good for the targets that we did reference. Now I press Next and Next, and I have the option to close out or just go straight to the optimization. So I'll select Close and Optimize. And now this is the same screen that I would have gone to if I just pressed Optimize to begin with, except you'll notice that it has automatically checked the box to utilize scale bar targeting. In addition to our standard color leveling, which you should always utilize, the AprilTags for loop closure, which were automatically recognized anytime I looped over multiple tags during my scan, and the plane parallelism constraints that we utilized flagging planes during our scan. So we want to take advantage of all of that and press Optimize Scene. This optimization procedure, as you just saw on the last screen, is leveling the colors throughout our scan, so cleaning up the data in terms of both color as well as cleaning up any noise or stray points that are recognized in the scan. It's also taking into account any constraints that were implemented, such as AprilTags for loop closure, plane parallelism constraints, as well as AprilTags for scale bar targeting in this case, referencing each of those known measurements to be applied to the optimization at this stage. The optimization procedure takes typically between 30 seconds for a small scan to as much as 5 to even 25 minutes for an extremely large scan. In this case, we're looking at optimization of about 1 to 2 minutes for this full room scan. So once the optimization is finished, you see a much cleaner, crisper data set. Any sort of blurriness or incorrect overlap has been cleaned up very nicely and accurately. And the colors have been leveled as well. As you captured so many different areas from different angles and distances, it takes all of that into account during the leveling of the colors. So now we can take a look at a complete scan of this electrical room. You have the option of looking at the point cloud view, which is what we're looking at right now. It's showing every single XYZ coordinate that was captured, and you can toggle the point size to really fill it in if you'd like. Typically the default should be set on 2. If you really want to dial down, you can make it extra small with 1, but you can just adjust that anytime throughout your scan. Similarly, you have the option to look at the point cloud view or the surface mode, which is the button on the top right, and you can just toggle that back and forth at any point. The surface mode gives us this photorealistic rendering of the point cloud, which can be nice, especially for certain types of data sets. It also has the benefit of allowing you to see through the foreground, which can be really helpful, especially in a room scan like this. If you're trying to take measurements and you want to see through the foreground, it can really help. But you can, again, just toggle back and forth at any point. Now we're going to go through some of the functionality that you have at your disposal once you've finished your scan. It's worth noting that everything that happens in Dot3D after the actual scanning itself can be happening on your device you captured with. This includes the optimization that we already did on here, or it can be happening in Dot3D Edit, which is our editing version of the software that includes everything except scanning and is available for your laptop or PC, for example. But in this case, we're going to do it all on the same device. So if I want to manage my coordinate system to make sure my scan data comes in upright in third-party software, or reference it to a known coordinate that I have from another scan or a CAD model, I can go to Edit, Coordinates. And you'll notice that Dot3D in this latest release is very intelligent about its guesswork and assigning the coordinate system automatically to the corner of the room. But for this example, let's say we wanted to put it in the other corner of the room. Now I select Set, and I can set a known coordinate, a known latitude, longitude, or just a generic 000 point, which we'll do in this case. So I'll select Pick Origin, and then I press and hold, and it gives me this zoom window to select exactly where I want to put that origin point. Assuming I'm happy with what I release on, then I press the primary button, and I press and hold on the floor to set my Z-axis straight up, and I press my secondary button, and I press and hold on the wall to set my X-axis out of the wall. Now if I want to toggle that to adjust it a little bit, I can do so with those buttons, and now I have my XYZ coordinate system coming out of that corner of my room, and every point on my scan is referenced to that as the origin point. So if I want to get a height of this stack over here, I just press Measure, Distance, and I can hold on the floor, and then press and hold on the top of the stack, and it gives me my point-to-point distance of 54.1, but also gives me my height of 34.4 from the floor to the top based on that coordinate system that we just set. You'll notice that my annotation tab shows that I already have one annotation. This is the one that we made while scanning. So if I select Complete Unfinished, you'll see that it automatically shows me the image of that annotation and asks me to confirm it. So I'll confirm that this will be a point annotation, and I can add in notes on that particular annotation. So we'll call this Fire Alarm 1. And I can select the arrows on the top right and left to add any more information. If there's a web link, like a part number, for example, I can add that here. Or if I just want to add description, you can add any sort of description details at this point. If you're happy with the details you've added, you then press OK and press Complete once you're done with your annotations. And you'll notice that what was before just a red X on my screen has now turned into Fire Alarm 1. Now that was the annotation that we added while scanning. You can also add annotations after scanning. So if I wanted to add an annotation to this April tag, for example, I just press and hold and add a point, call it AT1, OK. You can annotate not only to points, but also to planes in your scene. So if I wanted to get a surface area, it would be especially relevant if this room was completely empty, for example. I can do Annotate, Add Detect, hold on the floor, and select that I would like to make a plane measurement. Now this will automatically recognize that plane, and if you tap on it, it'll tell you the surface area, and those units can be toggled in the Settings tab. So another feature that we haven't touched upon yet, which is very important, is the cropping functionality. So this is back under Edit, same as our coordinate system management was, and we have two different types of cropping. We have the quality filter, which will basically take into account that same green and yellow feedback from earlier. So obviously I got the ceiling and the rafters at much further distance, so you'll notice that that data is a little bit more red than the rest of my scan. This is that same feedback from earlier, so those are areas that I captured in a light gray or a light yellow. And you can adjust the toggle at the bottom of the screen to a point that you're comfortable with, a threshold that makes sense for you, and filter out lower quality points. So this stray data through the window, for example, is definitely lower quality, and everything that's red will be cropped out when I select Apply on the bottom right. Now that can be helpful, but also sometimes it's easier just to use the standard traditional cropping tool to isolate just the data that you care about. This is a great best practice, whether it's a standalone scan that you're cleaning up, or if you're going to be registering it to another data set, you don't want all of those stray points to be taken into account during the registration. One useful workflow for cropping in a room type environment like this is the View tab and the orthographic view, which will allow you to look straight down on your data, kind of like a floor plan viewpoint. And I can do View, Vantage Point, Top. Now I'm staring straight down at my scan, and I can use the rectangular option to select the area that I want to keep. But as earlier, what I turn red is what I'm going to be getting rid of. So in this case, I want to invert, and now it's those stray points out the window that have turned red. If I want to chop the ceiling off, I can go to View, Vantage Point, Side, and just select straight through there. Let's say I want to get rid of all that. Now whatever's red, I'm going to be deleting, and I just press crop on the bottom of my screen. Now we can take a look at our cleaned up cropped data set, and everything looks very nice. I have an even smaller file size. It's a full multi-crop capability that you can do multiple times. So if I wanted to get rid of the top window frames here, I could do so by select, 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 and then just again press crop. Now there is no undo button, so this data is gone, but the good news is that every scan you take is backed up in its unoptimized format. So one, you can save your scan periodically to account for any issues you may run into. But two, no matter what, you always have that unoptimized backup to refer back to if necessary. You can access that by going to your Dot3D folder on your device and to the autosave folder.
Now, while we've already covered a lot, and we still won't cover it all, there are a few more features we should touch base on before we finish up here. So if you remember earlier while we were scanning, we captured a high resolution image of this electrical panel over here to get some more HD 2D detail of that particular area of interest. To view those HD images you've captured from your tablet or phone camera, you want to go to View, High-Res Photos. And in this case, we only captured the one, but you can capture as many as you'd like with the Pro version of Dot3D. And you'll notice it shows you this icon in 3D of where you were standing and where you were pointing when those images were taken. If you tap on the thumbnail on the right side, it'll bring you to that point in 3D, and you clearly don't have that level of detail in your point cloud. But if you press and hold on the thumbnail, then it'll bring you there in 2D, where you can zoom in, especially with the HD camera on this Samsung phone. I'm getting a very, very high level of detail in my 2D imagery, which is great to add value to your point cloud, and it all saves directly into the dot product file format. Next, we want to highlight the new multi-measurement capability available in Dot3D 4.0 or higher. So while we did take one measurement earlier, as you see in our Measure tab, you're no longer limited to one measurement at a time. You can take as many measurements as you like and save them all directly into your DP file format, just like you do all your different annotations and notes. So when I go back to my Measure tab, I can press and hold using that same drag and release workflow that we use for setting our coordinate system, and add as many measurements as I'd like throughout my scene. These all save directly into your file, and each one is individually adjustable, which makes it very, very precise, where I just select the circle and I can move from point to point within my cloud, getting to the exact point that I want to measure to or from. You'll also notice that in my measurement tab, it now recognizes the plane that I had created earlier in the annotation tab for the floor. So if I choose that I want to measure from the floor, I'm now actually pulling a perpendicular measurement out of the floor to anywhere I drag that to in my scene. So this is really helpful for clearance measurements. It doesn't have to be a floor, it can be any flat surface that you want to pull a measurement directly out of. Once you're ready to move forward with your scan, you want to go to the File, Save, or Save As option. And this is where we're going to add our file name, L515 scan 1, and I will often indicate what was done to the scan. So in this case, we optimized it, we set the coordinate system, and we cropped the data. Then you press OK, and it'll ask you every time you're saving or exporting your data what the output transform should be. So we set our coordinate system earlier. That's the user-defined coordinate system, which is automatically set and is what we'll use in this case. If I had known XYZ targets that I referenced, then I would maybe want to use the control target transform. Or if I use the design compare feature to reference to a CAD model, then I would probably utilize the design option. But in many cases, if you set the coordinate system using the coordinate feature as we did, you will use the user-defined option and press Save Scene. This is saving the data to the .product.dp file format. This is our own highly compressed point cloud format, which is very small in file size, easy to use here in the software, and in many of our third-party partner applications, such as Autodesk Recap, Cloud Compare, Leica Cyclone, and more. If you do need to export to a different point cloud format, that's also no problem. Instead of going to the Save As button, you want to go to the File Export button. And this will allow you to export to, in this case, 7 different industry standard point cloud formats. E57 is a very commonly accepted one that we'll utilize in this case. And we'll note that E57 only exports to meters. You'll see these notes on some of the different file formats we support. And we typically will want to keep 100% of our points so that you can decimate your data here if you'd like. And that covers our tutorial of Dot3D Pro on the Samsung Galaxy Note 20 with the Intel RealSense L515 LiDAR camera. Please stay tuned for more support videos across our growing lineup of supported depth cameras and tablet and phone platforms. For any questions, please visit dotproduct3d.com/support.